Welcome. In the current video, the process of performing fatigue analysis on spot welds based on the RUP method will be followed. For this case, a static model with spot welds, including two subcases, is used. The respective time history curves are assigned and analyzed in two events. The phenomenon will be studied in the time domain. To begin with, a new task is created, in which the model is loaded. For this action there are two ways. The user can load either the geometry or the results file. Easy definition of spot welds is succeeded through the Connection Manager. There is a seamless collaboration of ANSA Connection Manager with Fatigue Connection Manager. So, in case of geometry file, the connections can be identified directly if ANSA comments exist. Otherwise, if ANSA comments do not exist or in case of loading a results file, they can be detected automatically or defined manually through the Connection Manager. For this case, the geometry file is loaded. Open the Connection Manager from the Task Ribbon tab where the connections are listed as they are read from ANSA comments. The FE representation type, diameter, connectivity PIDs, and the respective thicknesses, length and the nugget ID are detected and assigned accordingly. For spot welds connecting more than two sheets, they are automatically split to two spot welds, adding the prefix _1 to the second one. New connections can be added by the pick button or automatically detected using the Connection Assistant. In this example, activate the Connection Assistant in order to detect spot welds that may not have been included in ANSA comments. In Detect options, select to search in all existing candidate spot welds and press Detect. Optionally, the user can search according to element type, nugget diameter, and length. Two C-bar elements are detected. Click on Accept in order to add them to the Connection Manager. The next step is to set up the material for the model. Access the material database, go to Internal Database and select Steel 1040. Copy the material to the user-defined list, in order to be able to enhance its properties. Go to Spot Welds tab and observe that the empirical scale factors used in RUP method are defined. The user can also change them to the desired values. If left blank, default values are taken into account. Moreover, as in the current scenario FKM mean stress correction will be used, move to the FKM tab to define the necessary parameters. The four mean stress parameters can be defined in three different ways. For this example, the option 1 slope will be selected. The user has to set the value of M2 parameter and the rest will be automatically filled according to FKM guideline method. Then, select the material and press the arrow in order to transfer the material in the Session Materials list. Switch to Assign Materials and choose Assign Material to Spot Welds. Select the material to be applied to all the connections. Assign the same material on the two sheets and the nugget. Moving forward, go to the Analysis Configurator window so as to fill in the necessary analysis parameters. The current analysis is a stress-based fatigue analysis on spot welds, in time domain. The input results are static, which means the internal forces and moments are multiplied by time history signals to obtain transient forces and moments. Generally, this process is linear and Gaussian. RUP method is used to generate the radial stresses. Rainflow algorithm is used to count the fatigue cycles and the damage is determined from Miner's rule. FKM mean stress correction will be used here. The next important step is to define the loads, so access the loads database. In the present session we will load the two time histories as curves from the appropriate file. Press the Import button and load the desired file. Each curve has 1000 points with a time increment of 1 second. Then, switch to Assign Loads to assign the time history curves to the static subcases. Two events will be created, each containing a single channel. Therefore, select Time Series button. In the window that opens, load the results file. Select the option Create Serial Events. Combine the two subcases with the two respective curves. Subsequently, the scenario has two events. The fatigue calculation is done per event. Finally, optionally specify an output path in order to save the MetaDB with the results that will be output. Select all in entities to calculate so that all the connections will be considered for the fatigue analysis. Keep in mind that only the elements that are assigned a fatigue material will participate in the analysis. Finally, run the analysis. Once the analysis is completed, results can be displayed through the dedicated plots of fatigue. Transparency can be applied to the rest of the model through the connection button. In the plot properties area, through fatigue analysis type, results such as damage, life in repeats, life in seconds, log of damage and log of life can be viewed. Analysis type results can illustrate the static condition, where the static internal forces and moments can be viewed. Both analysis types apply for every event, if exist more than one event. In the current scenario, the results can be viewed for every event separately. Moreover, enable the annotation on worst flag to create an annotation on the element with the maximum damage. Check the specific location, Sheet 1, Sheet 2, or Nugget, where this damage value occurs as well as detailed information. Switch to Post tab and open the time series plot. The input and the stress signals will be displayed, by default for the worst element and worst angle for Sheet 1, Sheet 2, and Nugget. The plot can be displayed for every event separately and for both of them. All 2D plots have a direct interaction with the model. So, by modifying the parameters, the plots are updated. Choose the events plot for an overview of the damage and life of all events as bar charts, as well as a total life and damage bar. Select the option Worst per event to see the worst element per event. Similarly, the events plot can be focused on certain elements, different location, or specific angle. For example, the user can select many different elements to display their results. Another capability is the rain flow matrix. Each identified cycle has a mean and amplitude value. Z-axis can be the number of cycles or the cumulative damage of the cycles that belong to this bin.